Hey guys, it's Michael here from FlySight. In this series of videos, we're analyzing a wingsuit flare executed by FlySight user Tomic. Our goal is to get an idea of what he can try in order to improve his flare height. In this video, we're going to look for the optimal flare given a couple of constraints that we've defined in previous videos. First, the track can only go down to 117 meters above the ground before the flare. And second, the aerodynamics are determined by the drag polar, which we fit to Tomic's flight data. Let's get to it. We've already loaded Tomic's track, set exit and minimum flare altitude, and fitted the red curve to his data in the drag polar. Next, we hit the Optimize button in the scoring tool. When we do this, FlySight Viewer will start looking for the optimal flare. As it works, it shows the best results so far. You can cancel at any time if this result is good enough. When it's done, we see the optimal flare as a dotted line in the plot view. In the scoring view, we see optimal selected, so the score, 73 meters, and the white bar in the plot view correspond with the optimal result. If we select actual instead, it'll show the score of 62 meters and the white bar for Tomic's actual flight. Does this mean Tomic can get a 73 meter flare from his suit? Maybe not. We made a few assumptions that may not be true. First, we haven't accounted for terrain. It may be that Tomic followed the approach he did because he was following the slope below him. The optimal path might go below that terrain. We also fitted the red curve in the drag polar using very limited data. In particular, we picked maximum lift to be somewhere in a large cluster of points. Despite these limitations, we can still get meaningful information out of this. Let's look at the lift coefficient plot, either by choosing it in the left menu or by hitting L. Roughly speaking, the lift coefficient is proportional to angle of attack, so we can think of this as a plot of angle of attack. The optimal solution holds 0 angle of attack, that's shoulders pointed into the wind, until about 7 seconds before the bottom of the flare, at which point it smoothly ramps up the angle of attack. At the bottom of the flare, it holds a maximum lift position, and it stays there until the top of the flare. Tomic's track is actually pretty close to this. He starts a little later, but this could be because he was already producing some lift to follow the terrain. Tomic ramps up angle of attack a little more gently at first. Roughly speaking, he holds the maximum lift position from the bottom to the top of the flare, but his angle of attack wobbles around a little bit. In the next video, I'd like to take another look at the drag polar and then conclude with some training goals that we might get from all of this, as well as how we can monitor our progress toward those goals. As always, if you have any questions, please let me know in the comments, and thanks for watching.